All right. Hey, everybody, welcome. Thanks for joining the September 2025 Zeek Community Call. These calls are hosted by members of the Zeek Leadership Team, and they're open to anyone in the community to join and participate. We typically share project and training news, a couple of community reminders, and usually the rest of the time is available for open discussion or other people to jump in and share what they're working on with Zeek. Topics for this month's call include development updates. Zeek 8 was released about 2 weeks ago, which is very exciting. So Christian, I'm sure, will share more about that and what's ahead, as well as some updates about upcoming trainings that we have this fall. And we also have a cool lightning talk today from one of our community members, Vince, who's going to be hopping in after our usual agenda items. And I'm super excited about that. Something new we're trying here to make these monthly meetings a little different, a little more interesting for folks. So let's dive into the agenda. Johanna, would you mind starting us off with some updates from the leadership team?
Sure. So the most important update by the Zeek Leadership Team is that we just started our yearly election cycle. So each year, half of the elected seats of the Zeek Leadership Team are up for re-election, which is a process that has quite a few phases. And at the moment, we are in the first phase in the project where people can either propose themselves or other people for membership in the Zeek Leadership Team. To qualify to be a member of the Zeek Leadership Team, you have to be someone who is active in the community. This does not necessarily mean that you have to be someone who writes code. It also could just be someone who is active on our Slack or forum, helping other people, someone giving talks, someone helping with testing of Zeek or giving training. So someone, you have to be active in the community and should be kind of known in some way. But that's kind of the only requirement. If you're interested in the work that the ZeekLD typically does, you can look at our meeting notes that are public. And if you either are interested yourself in helping with that or know someone who you think might be a great person to be on the Zeek Leadership Team, consider filling out our nomination form. The nomination form is open till the end of the day on the 12th of September. So you have a little bit of time, but not that much. So it's 9 more days at the moment. And that's the most important thing that's going on in the Zeek Leadership Team. Apart from that, last month, I think we mostly talked about the election. We still talked about the community survey, survey that was already talked about here in the last meeting. We had a little bit of discussion of potential upcoming events, which we will announce here in the future when things become more clear. And I think those were kind of the main topics.
Great. Thanks, Johanna. All right. Project news. Christian, take it away.
Hmm. Technical project news. Yeah, thank you, Michelle.
Technical project.
So yeah, as you have already touched, the obvious biggie this month is the release of Zeek 8, which we're really happy with in the team. Like it both went out on time and with essentially all of the features that we had hoped to ship. RC1 turned out to be really solid. We shipped an RC2 sort of last minute that corrected really minor things, but nothing that would even really count as relevant bugs. So that's pretty cool. It's holding up well so far as well. If you want to sort of understand the details a little more, we have a bunch of material coming up, but for now, we'd point you at the announcement blog post. That probably gives you sort of the best impression. From our side, we're really excited because it means that we're on track for switching to 0MQ as our default cluster backend in our next release in 8.1. And that's sort of where all attention is starting to focus at this point. So we're putting together basically our work items for that release. There's a little bit to do basically for making that switch, and in general also for that one and the releases after to sort of return to sort of like more classic themes for Zeek, like a future, analyzer development, making Zeek good at understanding traffic that's on the wire, sort of shifting back from all of this underpinning architectural work that we have put in place over the last several releases to enable that shift to 0MQ. So the latest and greatest is 8.0.1 that had very minor updates. We've also shipped 7.0.10 for those of you still on the 7 train. And we're about to try something for the first time that, like we'll see how it goes. And it's essentially like providing an upgrade guide for those of you switching from one LTS train to the next. That is on my plate right now, and Michelle is very patient with me. So I'm putting that together, and it's hopefully ready in the next few days or so. So let's see. I think those are sort of the biggies. Yeah, stay tuned for sort of deep dives on the various features in Zeek a little bit to appear sort of in blogs and in videos. And meanwhile, the dev team will sort of, go heads down and start planning out 8.1. Thanks, Michelle. That's all I have.
Some good stuff. Lots of exciting stuff ahead. All right, I'm going to be filling in for Fatima on the training front, and then I'll do a quick community update before passing it over to Vince. So let me just look at my notes here to make sure I cover everything. All right, so for Zeek training, we have our Introduction to Zeek training happening at the NSF Cybersecurity Summit, which is taking place on October 20th in Boulder, Colorado. Registration is open for folks who are interested. We are going to be sharing some links in the newsletter and on Slack if people are interested in learning more or attending. I was taking a look at the full kind of summit agenda last week, and it looks like there's a lot of stuff going on there, but we pretty much have a dedicated day for Zeek on October 20th. And it is my understanding that we have kind of 2 training slots available, and one of them is open. We're looking for someone to fill that slot and run a training. So if anyone watching this is interested in giving an in-person training on October 20th in Boulder, Colorado, then let us know by the end of the week. Feel free to send me a DM or go into the training channel on Slack and let us know. We'd be happy to work with you on that. All right, moving on from training to community very briefly. I am starting to hear back from people who raised their hands to share some of their real world use cases for Zeek, which is super exciting to see. I know that was kind of something that I have heard a lot from the community, is that others are just really interested in seeing how people are using Zeek in their day-to-day. So we're trying to figure out how to provide that for people. So I'm hearing back from people. I'm going to figure out the best way to share these use cases with the wider community so that people can really learn from each other and understand how people are using Zeek, maybe begin thinking about using it in new ways and all that stuff. So we'll see how that goes. If you are here now, or you're watching this recording on your own time and you're thinking, oh, I'm actually doing something really, really interesting with Zeek, and I'd be willing to share that use case with others, go ahead, reach out to me. I would love to hear from you. And there's really no one specific thing that we're looking for. I've seen a lot of different use cases come through my inbox. So a lot of different use cases from different people, different roles, different industries. And what I'm really looking to do here is, again, highlight what people are doing, how they're doing it, help us learn from each other in that process. I'll say, something that comes up a lot is, privacy and sensitive information. It's probably the case for a lot of you all. So I'm definitely open to kind of making things anonymous or working in a way that's feasible for you. And I'm having conversations with a couple of community members right now about that. So stay tuned. Sky's the limit. I'm excited to try something new and hear from more people. So yeah, my inbox and my DMs are open for that. And that's going to be my community call to action this month. And with that, Vince was actually one of the people who raised his hand to share a little bit more about different use cases for Zeek. So I would love to turn it over to you, Vince, for a quick talk on Zeek and post-quantum cryptography discovery.
Great. Thank you, Michelle. Nice to see everyone. And I've got till bottom of the hour.
We typically wrap this up at half past, but sometimes we go for another, 10, 15 minutes.
So, okay, 15, 20 minutes. All right.
Yeah.
I'm Ben Stouffer. I'm field CTO now at Corelight. Been involved with the Zeek project for a long time, and so was happy to raise my hand to talk about a use case that's been coming up increasingly in my work, and something I've been talking to a lot of people about, especially in the federal government recently. And so I thought it was a cool one to share for those that, this may not be on your radar or may not be on your radar, but you're not kind of familiar with what Zeek might be able to do here. So I'm going to touch on very briefly, like the high level problem, and then spend most of my time talking about how we can use Zeek to solve some of the problems that I'm hearing about from customers of Corelight, but also just people in the community that are struggling with this challenge. So what is the real challenge, right? We have a bunch of encryption algorithms that are, created by essentially mathematical, challenges that computers have to solve, right? And the underlying encryption structure that we use for everything from TLS to public key infrastructure to all that is underpinned by these various algorithms, right? And what has changed recently is, these algorithms have continued to change and migrate over time, and we always continue advancing that, entire industry of cryptography. But the advent of quantum computing is something that has kind of changed the game, right? So the principle of quantum computing is that it can accelerate the sort of solving of these sort of mathematical challenges in a way that could leapfrog well beyond what we kind of expect and what computers can do now, right? So the problem then becomes much of the symmetric keys that we use for actual encryption are still safe to quantum computing and are expected to be for, at least the near future. But the public-private key infrastructure, the asymmetric encryption that we essentially rely on to share those symmetric keys, and which is, again, underpins all of TLS and a number of other protocols, right, are potentially vulnerable. Some of the algorithms that are used are potentially vulnerable to quantum computing cracking, right, to being essentially reversed by these quantum computers in the future. And so the question for all of the users of this cryptography becomes, when does that happen? And nobody really knows, right? There's all sorts of predictions, but there's no, like right now, quantum computers cannot crack these algorithms. But there's the prediction and the assumption that they will be able to at some point in the future, and when what that means. So the challenge becomes, if you could then harvest traffic now, right? Start saving traffic from a company, from a government, from whoever. Store that traffic so that by the time the quantum computers can start cracking some of the algorithms that would allow you to essentially decrypt, and retrieve symmetric session keys for some of the traffic that you have captured, you could then go in and decrypt that traffic and actually see in plain text all of the stuff that you were trying to communicate with these algorithms. So the problem is, I mean, a bit esoteric, because it's like, well, wow, who could possibly harvest all of this information and save it for years and then want to go back and decrypt it? But for advanced companies that have intellectual property, for governments that are transferring massive amounts of information, this actually becomes a real thing they're worried about. And so a lot of the focus around discovery and understanding what algorithms are being used and how those algorithms will migrate over time to something that is post-quantum ready, right? That is capable of withstanding these quantum computer potential disruptions in the future. It has been a real focus, especially at the US federal government, right? And so there have been a number of different initiatives and compliance mandates around post-quantum encryption and how it gets used in the government. And so essentially, the government is charged with saying you need to understand your cryptographic assets. You need to understand what algorithms are being used, right, in your various computer systems and applications. You need to be able to kind of describe those, and you need to be able to have a plan of how you're going to migrate off of ones that are not post-quantum ready and into something that could potentially withstand a quantum computer attack in the future. So that's the challenge. That's the basic high-level overview, and there's a lot on the details of it. And like, I'm not a math person, even struggling to understand how the quantum computer stuff works, how that would happen, etc. Goes down a very deep rat hole. But I'm a network guy, and that is the fun part of it, right? And so what we talk about then is how Zeek can help us basically do the understanding of what is being seen on the network, what are those algorithms, and how could we help kind of a customer or a user give an inventory, discover what's being used, and then plan for some sort of migration that might be mandated by their company or by a compliance mandate or some sort of other regulation. So Zeek becomes a very powerful tool for this. And I'll spend most of my time kind of talking on this slide because this is where I then usually start talking to people who aren't as familiar with Zeek about what it can do. But I think it's also really important to say that this is just one aspect of that process, right? Of what some people describe as automated cryptographic discovery and inventory. There's actually an acronym for it, ACDI, that the federal government uses. But that involves a bunch of different pieces, right? You could have, algorithms that are being stored and used across the network. You can have stuff in your repos for code. You can have public and private key infrastructure that are storing those things for use in digital certificates, etc. You can have stuff in memory looking for these certificates and the algorithms being used, etc. So there's a bunch of ways to wrap your hands around this problem. It's not just network, right? But I think Zeek has an especially awesome view of how to capture this data on the network and how to be able to use that effectively to help people understand this problem. So, of course, what do? Zeek can capture and gather traffic on the network. And so, of course, we can do that in a physical environment. We can do it in a virtual environment. We can do it in the cloud. So people can think of deploying their Zeek sensors wherever they might have these sorts of applications or devices or services that could be running. Of course, we do a bunch of analysis. Zeek's engine is particularly well suited at analyzing TLS and SSH, a couple of the most important protocols that have kind of quantum, either usage of those algorithms or, a great importance when it comes to making sure you're understanding what's being used there. So to just kind of go down the list, obviously we can do full deep packet inspection for most of the protocols where post-quantum encryption would be important to understand. We can do the full metadata extraction for SSL and TLS. That's important because oftentimes these algorithms may be tied to a specific certificate, and you want to understand where else that certificate is being used, what applications or services it's being tied to, etc. One of the most important things is that Zeek can understand, at least with most versions of the algorithm, even including TLS 1.3, right? We can capture a bunch of the cryptographic capabilities during the initial hello or the exchange between the client and the server, right? So not only can we say this particular connection was using encryption that was post-quantum ready, we could say, actually, it wasn't, and here's why. The client said, hey, I am capable of using a post-quantum cipher, and the server said, I don't have that, sorry, I can't use that, right? That's extremely important information where you're trying to do a kind of an inventory of what assets you have and how you can use them. So with a little bit of tweaking, right, Zeek can easily provide a list of not just what were the algorithms used in the connections that I see, but what are the potential algorithms that could be used by all the clients and the servers in my network, which is a really interesting and important piece of this discovery. Currently, we can map all the RFC ciphers and curves that use post-quantum encryption to kind of their well-known names. So these names are developing and changing over time. And in fact, they get one name and then they like change it to something else and then change it again. So it's important for people to understand the names of these curves rather than just like a curve number. But if we don't understand and don't map to a well-known kind of name, at least we capture the number. And so this is kind of a potential for opportunity mean, the future is to continue that, and something I've talked to Johanna about, to continue mapping and tracking the names of these curves to something that's kind of human readable. So when people see it in a log, they're like, ah, okay, got it. Yeah, this makes sense, rather than having to go back and do this, decoder ring thing. Obviously, mapping the rest of what Zeek does so well, right? Mapping protocols and services and doing application discovery, that sort of stuff really ties into the power of Zeek as a tool for this use case. Because again, you're not just looking at TLS and saying, okay, I'm looking for this kind of cryptographic information. You're saying, what does this mean? What is it tied to? Oh, well, it's tied to this particular service that's running on this server that's also being used by these other clients, right? You can get all of that information. So you can start tying together not just crypto info, but also info about the services that are using it, the clients that are connecting to it, time periods they're being used, right? All the good stuff that network connection metadata can bring. And of course, DPD, working across all ports, dynamic protocol detection is another boon here, because oftentimes TLS could be used on an odd port or something unusual. And if you're just looking on port 443 for this information, or you're hard coded in some way, like, you're not going to capture that. So it's a nice way to highlight a capability of Zeek that's kind of built in, that really helps accelerate this sort of discovery. Once we've done analysis and decided what we can extract from the traffic, then of course we have to deliver that data to somewhere. And so being able to deliver that information into an existing SIM or workflow is something Zeek's pretty good at, right? So this can send downstream into a customer or a user's environment. It doesn't have to just live on the sensor, and that's important because oftentimes from my discussions with various organizations, there are now actually, at least in the federal government, there will be an entire department focused around post-quantum cryptography, the discovery, the inventory, the assets, the migration. And these aren't like IT people. They're mostly, like compliance folks, right? And so they need to just have the information like in a spreadsheet or in a log or something that they can make sense of and say, okay, great, the network team or the security team helped us find this information out, but we're going to put this into a big database or, spreadsheet or something to track this for the whole organization. So the flexibility in export is nice. Obviously, being able to keep this data for a long time is also nice. So the fact that Zeek's metadata is compact and can be kept in long-term storage, right? We always use the example that LBL still has all of the Zeek logs back to the beginning of time in the mid-90s, right? So you can track cryptography over time. You can see how these algorithms actually kind of began and were generated and then started being used and then went by the wayside and another one kept up. Johanna's done some amazing work in this area using Zeek data over time, and others have as well. So just one more use case for being able to track, how cryptographic algorithms are used over time and how you can, see that as in a historical view, which is pretty neat. And that's also super relevant for the migration type of project, right? Where you say, great, well, last year we had 20% adoption of post-quantum crypto in our primary applications. This year we have 40%, right? We've seen a 100% growth rate. So that kind of tracking is important, not just for research purposes, but for actual, real life operational challenges. So that's kind of the idea that I lay out to people of how Zeek can help, and then a few real world examples, right? So here's some examples that we took. We generated some dashboards using data to say, like, well, what would this actually look like in the real world, to take some of this and graph it out. So in this case, you see a curve summary for TLS that's using post-quantum crypto curves. So you've got a server name, you've got the curve name here, and you can see how, again, some of these are kind of labeled with a more or less human readable name like Kyber, which is one of the primary ones that's been adopted by the community and RFC compliant. And then you have some that are just like unknown 4588, right? So if we could get those all to be kind of labeled appropriately, that would be helpful. And then you see like this checkbox here, is this a post-quantum curve? Of course, graph this over time, put it into different spreadsheets or charts or whatever you want, right? And you can start to see this data and help understand and make use of it on your own environment. A couple other examples. Here's one for SSH. SSH is an interesting example because as of OpenSSH 10.0, which is recent, I think in the last like 3 to 6 months, they adopted a key exchange algorithm that is post-quantum capable as the default. So now you see, right, we've got a client and a server running OpenSSH 10, and it's using this post-quantum capable key exchange algorithm. All the rest that we were seeing on this network are not. So it's an interesting one because all of a sudden it popped up in the data immediately, like the next day after that everyone updated their OpenSSH. If they were using the defaults, then all of a sudden everyone was using this new algorithm and it was on by default. So kind of cool. Couple other examples just kind of showing the depth and richness of the SSL and TLS data, of course, where you could see things like what are the TLS versions, the ciphers being used, the subjects of my certs, etc. This is, kind of traditional stuff that Zeek is already providing, but in this context, it helps to illuminate like just how much information we're actually capturing in that metadata and how useful it can be in this particular context. The next one is one that I took an idea from that someone had already published online, right? And this was some researchers and Zeek users who had done something very similar, but essentially by using the TLS extension script, you're now capturing, again, the client curves and the chosen curve. So in this case, we have a bunch of different IP addresses, highlighting that, of course, we can do IPv6 or v4, no difference. And then in this case, we're showing the version of TLS. We're showing the chosen curve that actually was in use for this particular connection. And then we see the client curves that were offered, right, that were exchanged at the beginning of that capabilities exchange. So again, if I wanted to go in and find out which of my clients are capable of using post-quantum ciphers, but were not able to because my server application wasn't able to, I can do this with a simple log, right? And I think this is a really key piece of saying this is the power of Zeek to be able to extend the data that we extract from the network, take those features out of the network and do something with them that's really useful and that may not have been thought of in the past as something super great. But in this use case, it's absolutely critical because it now becomes the difference between understanding what you have or don't have and how it's actually implemented and being used on your network. And I have a couple other examples of just like, going through the log and talking about like, hey, here's everything that's in the TLS log, it has full transaction details, validation, etc. SSH has, essentially an exposition of each of the different algorithms that were used, the key exchange algorithm, the cipher algorithm, the MAC algorithm, etc. Right? So we have tons of cryptographic information that is there, but it's also very focused on, being compact. Like we don't have just, everything that's ever happened. We've got this nice compact log, but if I'm looking for particular cipher suites, I can zoom in on that and do a quick report or a quick, graph or whatever I'm looking for. Same thing for X509 and connection log. So that brings me to really the end of just describing this is how I usually have been talking about this to people. It's gotten a lot of interest, again, especially in the federal government, but also in financial institutions and other groups that are really focused on either privacy or secrecy or, just the idea of being ready for the post-quantum world. And of course, we really don't know when this is going to matter. So I think it's the most paranoid and perhaps the most prepared that are trying to get ready for this right now. But it will become increasingly important to everyone to make sure that their information, your banking information, your information that you're using every day across encrypted algorithms stays that way. So there's other ideas for kind of improving this. I think, again, trying to get that translation of numerical values into human readable curve names would be nice. Being able to kind of add different logs and maybe even focus this in as a use case is something that I'm exploring with our customers and definitely share, what I hear back in the future as this continues to develop. So I think I'll stop there and see if anyone has any questions.
So cool. Thanks for the crash course.
I learned at least one acronym, Vince, like ACDI, I had not heard before. So thank you for that. Awesome.
Yeah, any open floor for questions or comments or feedback.
Have you identified any obvious blind spots, Vince, like where things where Zeek sits on the information but is not telling you right now? I guess that's sort of an obvious question, but
No,
is
I
it
don't think so. I mean, I think it certainly involves a discussion, especially with people that are less technical or less focused on,
mm,
security operations. They kind of see it as, oh, I can see all of this in my environment. It's like, well, no, wherever you are instrumented to have visibility, you can see this information. So
mm,
if you're at the border and you're really worried about what your clients on the internet are talking to your public applications, great, you're probably covered. But if you're worried about internally between, organizations or data centers and you don't have that instrumented, then of course you're not going to see that. So I think just the making sure that people understand you've got to have visibility into the network components that you want to see before this information will become available to you.
right. Got it. Yeah, very cool.
Great. Well, thank you
Awesome.
for the opportunity to chat. And yeah, you can hit me up with questions anytime on Slack and Zeek or at my email, InSecOrLight.
Awesome. I'm excited to share this with the folks who typically watch the recording after. I think this will be really interesting for a lot of people. So yeah, Vince, thank you so much again. That was a great way to kind of kick off this new thing we're trying out. So I appreciate it. All right. Well, we'll wrap up. That's it for September. The next community call is on the calendar for October 1st. So keep an eye out for news and information about that. And we'll see everybody on Slack, and we'll see you next month. Take care, everybody.
Bye, folks.